Hello everyone, welcome to Cloudy Tech. This is my new YouTube video channel I've been thinking about for a long time, and then now finally I got time to action on it. The aim of the channel is to demystify technologies. Technologies these days can be very hard to understand and can seem very mysterious sometimes, so I'm hoping through this channel I can present to you the most interesting technologies in the simplest words. The first few episodes we're gonna start with something I've been fascinated about since I was a kid, so building a gaming PC.
So my last PC was a Thermaltake P5 open-air chassis, and now I ended up with this little case on my desk. My previous Thermaltake P5 build was brilliant. It's one of the best cases to show off your hardware, your effort and money you put in, and the RGB lighting, of course. However, it's too big for my new home, and it does accumulate a fair bit of dust over time. So here and there you have to open it to vacuum the dust out so you don't lose too much of air ventilation and cause thermal problems. With the need for a smaller PC, I did tons of research on mini-ITX cases. I don't want to compromise the performance too much. I'm a casual gamer and I use my PC heavily for photo and video editing. I also run a few virtual machines here and there to test things around. After reading tons of reviews and learned the big names of the most demanding ones, such as GhostX One, NKSM1, Ryzen Tomahawk, etc. However, the wait time, and the price has really put me off until I found this gem in front of you. I purchased this cooler Master NR200P case locally in Australia and paid $150 for it, which is equivalent to 110 USD. It's about 1/3 of the price of the popular ones I just mentioned. I had it now for more than half a year, and honestly, I don't have anything to complain about. With the money saved, I managed to put in a Ryzen 5950X 16-core CPU inside of it, and with a bit of luck, I also managed to get my hands on a RTX 3080 end of last year just before the price went up. This case has offered two side panel options, a tempered glass and a perforated side panel, one for showcasing and the other for performance. I have to admit I'm on the greedy side to use tempered glass with vertically mounted GPU, especially both CPU and the graphics card being top of the range and generate considerable amount of heat. I believe many of you are thinking about the same, and this is what we're going to look at in this video, how feasible this setup is. Currently, I'm using Corsair H100i with a 240mm radiator at the bottom for air intake and the CPU cooling. Below the top panel, I have two 15mm fans from Noctua Chromax. As mentioned, I'm planning to convert this into a custom loop water cooling, hence why I went with slim fans on the top. We'll discuss more about this later. So let's take a look at the system and some gaming performance, and followed by a few benchmarks. The system is on default for everything. It has 32GB RAM running at 3200 MHz. Other than that, there's nothing special. There's no overclocking or undervolting, everything's at default. So for each game I'm testing, I'll quickly show you the settings, which is set to highest or ultra, and each game is running under 4K resolution. I'll run the game for a little while until the system reaches equilibrium. For a more controlled testing environment, I have manually set the GPU fan at 2000 RPM, which I think is a reasonable speed with a reasonable amount of noise. So the Witcher 3, I'm just running outside of this bloody baron on a bridge, back and forth, and let's see how we go. So this TUF 3080 from Asus is an overclocked version, and the boost clock speed is 1785 MHz. It has an overclock speed which is 30 MHz higher, setting at 1815 MHz. It's not much, but it's what you paid the $100 for. So finally the temperature has gone over 80 degrees. It's stabilized at around 81. And once it's over 80 degrees, I feel the GPU clock speed is throttled a little bit. As you see, we're seeing more 1700 MHz than 1800. So the card is running at gaming mode instead of the overclocking mode. And the frame rates varying from 65 to 70 FPS, depending on the exact scene you're trying to render. Okay, so the next game we're going to test is GTA 5. It's an older game, so we expect to see higher performance. The frame rate is starting at about 130, 120 FPS. So after about an hour, the temperature stabilized again at around 80, 81 degrees. Frame rate fluctuates around 80 FPS while I'm driving. And the GPU clock speed constantly stays above 1800 MHz, which is pretty good. Cyberpunk 2077, that is the last game we're going to test. As the latest game with ray tracing enabled, this is something that definitely want to be tested on RTX 3080 graphics card. I'm just going to drive on one of my favorite roads in the game for the next 20-30 minutes and see where we get. So being one of the latest ray tracing games, Cyberpunk is definitely doing a much lower frame rate. Even with the static scene, it's doing around 50 FPS. While I'm driving, it fluctuates around 40. So after about 15 minutes, the temperature again stabilized around 80 degrees. Frame rate is hovering between 45 to 50 FPS while I'm driving. And now I'm just gonna go to a more crowded place with more NPCs around. So here I'm standing outside of my home with a lot of people around me. And temperature fluctuates around 77-78 degrees with the clock speed at 1860 MHz, which is 45 MHz higher than expected. However, we can see the card is struggling a little bit with the people around. The frame rate is just slightly above 30 FPS. This is just what you have to pay for if you wanted the most advanced gaming technology enabled. So after 3 games tested, we see the temperature is kept around 81-82 degrees max. It's definitely on the higher end, but it's nothing that needs to be overly concerned. It's just something that you need to tolerate if you choose appearance over performance. If you are okay with the perforated side panel, at least you see the graphics card to be 5 degrees cooler. In 3D Mark TimeSpy Extreme, it scored just below 8000. And in Firestrike Ultra, it scored 10289. It is a little below average. If you have a similar system, please let me know your score in the comment area below. Okay, so the next test I did is FurMark, both GPU and CPU load. If you ever question the feasibility or stability of this system, this is gonna answer you. And you can't stress the system more than both CPU and GPU loaded at 100%. I've run this for about 15 minutes. As you can see, GPU again kept around 80 degrees while CPU hovers between 63 to 65 degrees. The AIO coolant went up about 3 degrees. There is nothing wrong, and I'm sure it will continue to run for hours. Okay, the last test we did is in CineBench. In CineBench R20, multi-core test is able to achieve 9200 at default voltage, pulling about 100 watts. All-core speed settles around 3.7 GHz, nice and cool with a maximum temperature of 65 degrees. If we let Ryzen master to auto overclocking, CineBench R20 is able to hit up to 10,500, which is a 14% increase. However, at the same time, max temperature is getting close to 90 degrees with an additional 100 watts of power pumped into the chip. All-core speed rises from 3.7 GHz to 4.3 GHz. This temperature and power consumption is way too high for me. I prefer to keep it on default, stay nice and cool.
Okay, I hope you have enjoyed watching the video. I hope it has given you a basic idea on the performance of this build if you are thinking to build a similar one. At the same time, it gives us a baseline that we can use to compare with after converting this PC into custom loop water cooling as I promised. I believe many of you wonder the same if it's worth to build a custom loop water cooling or spending the money. I hope we will find an answer for you in the following videos. A huge thanks to you for watching. If you haven't already subscribed to my channel, now could be a good time. Thank you very much and see you next time.